Thank you for that introduction. I'm really pleased to be able to present at the Embedded Vision Summit today. And so in this tutorial, I'll show you how to build an object detection model using the Edge Impulse platform and a Raspberry Pi. So I've got my Raspberry Pi 4 here with the camera module attached to it. And basically object detection can be applied to many industries, like if you need to count objects or people, or if you want to sort objects from a conveyor belt, for instance. And so in our example, we are going to build a model to detect different tools. A screwdriver and a tape measure. So let's get started. Okay, so to get started with your Edge Impulse project, the first thing you need to do is to select the type of data that you want to work with. So in our example, we want to do object detection. So we select the images category, and then here we select the classify multiple objects. And the last screen here basically helps you with how to collect new data from different development boards, existing data sets, and we've got also a link to different tutorials. So we're going to get started. And so the first thing we need to do now is basically add our Raspberry Pi 4 to our project. So for that, we head to the devices section. And from there, so you can connect new devices. One cool thing actually, if you don't have the Raspberry Pi, is you can use your mobile phone as well. So like if you go here, you just scan the QR code with your mobile phone and you can start collecting data directly from your smartphone. But in our case, we're actually going to use the Edge Impulse CLI running on the Raspberry Pi 4 to do that. So I am connected to my Raspberry Pi right now. And what I will do is run the Edge Impulse Linux command. So the first time you will run this command, it will ask for your Edge Impulse credentials. And then you will need to select which project you want to send the data to. And so in our case, we select the object detection tools. So it's detecting the microphone on the Raspberry Pi, the camera as well. And we can give it a name. And now we can start collecting data. And so you see now when I go back to my devices page, you can see that my Raspberry Pi is actually connected. So now from the data acquisition page, we can start collecting new samples from the Raspberry Pi 4. So we can see here that the Raspberry Pi is already connected. For the label, it doesn't really matter because at the end we will draw some bounding boxes around the different samples that we have collected. I select the camera sensor, and then what I will do is I will basically point out the Raspberry Pi camera to the different tools that we wish to collect. So I can start by collecting a sample of the tape measure. Can take a different one with different angle. I can do the same with the screwdriver. Okay. And of course, we can have both objects in the same snapshot. So let's do that. And basically, to have good accuracy on your model, you will need to collect roughly 30 samples for each object that you want to detect. So let's keep going and collect a bit more samples. We will just vary the angles, zoom in, zoom out. And so once we get the 30 samples, we will go through the impulse design. So we've collected roughly 60 samples now, as you can see from the screwdriver and the tape measure and both. And then the next step is basically going to the labeling queue to draw bounding boxes around the different objects. So here in this case, we've got the tape measure, and so we can do that. We call it tape. We save the label, we go to the next one. And what is interesting is that the labeling queue actually also recognize once you've labeled an object, it will try to detect if it's something you've already labeled previously. And so here we can see that the bounding box is pretty good. We can just adjust it a little. We keep going. So here we don't have the tape, but the screwdriver. Do that. We'll readjust the bounding box. Oops. Probably like this. We save. Okay, detected the screwdriver here as well. Here we've got also the tape. And so we just keep going, and we can see that it's actually working really well to automatically detect. So you don't need to label by hand each of your sample. So let's just keep going until we reach the last item. Okay, so we just finished labeling our data set. As you can see, we've got our 60 items with 34 items of measure tape and 43 of screwdriver. So for now, everything is in the training set actually. So we could have collected data inside the test set, or we could actually move each samples manually. But a better way to do that, and it's also because we want to keep like 20% of our data set as a test set. What we will do is we'll go into the dashboard, and from here we will actually use the rebalancing data set, where basically we'll keep 80% in the training and then put 20% in the test set. So rebalance data set. Okay. And now if we go back to data acquisition, you see here that we've got now 48 items in the training set and 12 in the test set. So we've completed the data acquisition. Now we're going to move to the impulse design to create our machine learning workflow. So we keep the default parameters here for the image data. We fit the shortest axis because actually we are not capturing square images with the Raspberry Pi camera. And then we just add the image processing block here. And finally, the object detection. We save. And then we can move to the next step to go into the image here. And so we'll just use the default RGB parameters for the color depth. We save, and from here we can generate features, and the features will then be fed into the neural network that we will use for object detection after. So it's taking probably like a couple of seconds to finish generating the features. And once it will be done, on the right side, we'll be able to see the feature explorer, which is like a nice 3D view to see like if we have some clustering between the different objects that we want to classify and to detect. So here you can see like in blue, that's basically the screwdriver samples. We can select each of them individually. And in orange, it's the tape measure. It's actually not too bad. We've got this one, which is a bit, probably like here it's some mislabel, as you can see. But we'll keep it that way for now. So we finished generating features for the image. Now we move to the object detection learning block. So in the object detection learning block, we basically use a transfer learning technique using MobileNet v2 And basically we fine-tune the weights of the MobileNet v2 based on the data set that we have. So we keep the default training settings here. MobileNet v2 is selected. And then we start training. And so it's going to take a couple of minutes to finish the training. And then we will be able to see what is the accuracy of our neural network model. So we finished training the neural network, and as you can see, we've got quite good accuracy for our model with close to 82% precision score. So that's actually the precision score for the quantized model. We can also switch to the unoptimized one. And for this one, we've got actually the exact same score. The difference between the two is the unoptimized will take more space in memory. So like here, you can see that the RAM usage is a bit more than 10 megabytes, whereas the quantized version is 3.6. So we finished training. Now what we will do is we will switch to the model testing and see how well it performs on a new data set, because the neural network hasn't been trained on this particular test set. And if we look at the results here, we've got something very similar with close to 78% accuracy on the test set. We've got a few of wrong items. We can look at each of them to see the details. Let's look at this one. So for this particular one, we are supposed to detect both the tape measure and the screwdriver. And we can see that here in the classification results, we've got only the tape, which is actually detected. Like if you remember, during the impulse design, we decided to keep the shortest axis in order to make square images. And as you can see in the classification results, because we basically keep only part of the image, the screwdriver doesn't appear completely on the image. So actually, in this case, it's not such a bad result. We can look at the other one, which is this one, the tape. And here it actually detected the tape correctly, but with some score which is actually a bit low. That's why it's actually flagged as a low precision item here in the test set. Okay, so we've basically done with the model training, testing. So the last step basically in our workflow is to go into the deployment section. And here in the deployment, so this is where you can decide to create different libraries, build binary firmwares for the different boards that we support, or basically also retrieve the model directly on the Raspberry Pi using the Edge Impulse Linux CLI. So in our case, we are not going to use one of the libraries. We are just going to switch directly to the Raspberry Pi. And I will stop the data collection CLI. And I'm just going to run the Edge Impulse Linux runner command. And what it will do is it will, because I am still connected to the exact same project, it will download the models that we have just trained, compile it for the Raspberry, and then create a binary out of it to run the inference directly on the target. And so once the model is downloaded, we don't need an internet access on the Raspberry to run the inference. So our model has been compiled, and as you can see now, it's actually running on my Raspberry. Right now, it's not detecting anything because my camera is not pointing to anything in particular, but let's move the camera and point to the tape. Okay, you can see it's detected correctly. And now if I move, let's try the screwdriver. Yeah, working fine. And we can try to get both at the same time, which we can see here. So it's like really good to see that in the CLI, but we've got actually something even better. On the Raspberry Pi, there is actually a web server running. And so we can connect to the Raspberry Pi HTTP address directly. So you can actually retrieve this HTTP address here. I paste it there. And now you can see that I've got the camera in my hand and setting the tape, the screwdriver. Perfect. So I hope you've enjoyed watching this tutorial and seeing how easy it is to create an object detection application. So for more details about Edge Impulse, you can visit us at edgeimpulse.com, and there you can sign up for a free account and start building your own machine learning project. And now I'll be happy to answer any question you might have.